I apologize. I was not working on my slides 1 minute. I'm not one of those presenters, but I was very late, so I apologize. Thank you so much. I am David Aronchick. I lead open source machine learning strategy and ML at Microsoft and Azure, and I was previously the lead PM for Kubernetes, and I helped start the Kubeflow project. And I'm here to talk to you about how to bring your machine learning to production using Kubeflow and MLOps. So at Microsoft, I guess this little widget is not working. All right, I will be operating from my laptop. At Microsoft, we do have a lot of experience bringing ML to production. We bring together your data, we bring together cloud, your models, and our job is really to help customers, large customers, small customers, whatever it is, help you move through. And this is something that we have a lot of experience doing. We have a lot of internal experience around Microsoft Research and ML generally, with many of the most recent benchmarks and achievements from ML coming out of Microsoft Research. We're really, really proud of that. And of course, we do give all those back to the research community in the form of open papers and notebooks and data. And the reality is that ML does touch every aspect of Microsoft today. Literally every one of these logos and many more, from your customers, clients, rich clients, dead clients, or thin clients, whatever they may be, Xbox, phone, you name it. We're using ML in all of these various places. And we're using it at enormous scale. 180 million Office users today, every day, use Office, AI features in Office. We have 18 billion queries asked of Cortana, which is obviously rich NLP and other things, and 6.5 trillion security events evaluated every day. There's simply no way that we could operate and process this data without something like machine learning. So this is the point in the slide where everyone's like, wow, that does sound really great, except they also say this, right? ML is hard. And it's really on us, those that build these platforms in the ML community, to help folks get there better. Because we know something that a lot of new people to ML don't know. And that's the following. Today, a lot of people new to ML think that it's all about the model. And I understand why. Every new article out there talks about, well, Google just released BERT, or Microsoft released this, and AlphaGo did this, and it's all about this amazing model that they built. But it's not. It's about the data processing and cleaning and all the various things that are involved in actually bringing something to production. Because that's the nature of machine learning. It is these many, many microservices, each of which have a very specific functionality, often very specific tooling, that do very specific things well, but then need to be coupled together in an intelligent way. And if you just focus on the model, then you're going to be in trouble. And now I know what you're saying. You're saying you're a data scientist and you don't care. And I believe you a little bit. But I'm here to tell you, you actually do. And the reason is tweets like this, right? Models are relatively easy to build, but they are very hard to roll out. Because more often than not, data scientists operate in a way that they are familiar with. They understand their tools and they build using their tooling and local laptops and local clusters, but they don't know how to reach out and roll it to production. And the reason is because you have this separation, right? The data scientist is over here, they're trying to iterate as quickly as she can. She wants to use frameworks and tooling she understands. She wants to mix and match tools, the absolute latest build of TensorFlow or PyTorch or Onyx or whatever it may be. Somebody from Carnegie Mellon just launched a brand new tool around reproducibility and introspectability. And that's great, she should have the capabilities to do that. She also wants to not worry about management because it's just her laptop. If something goes wrong, she can flatten it and restart. And on the other hand, she wants unlimited scale. She's got a paper due, on Thursday at 5 p.m. She wants all the GPUs in the world in order to achieve the results she needs. On the other hand, you have the SRE, right? And she needs consistency, she needs observability, she needs to reuse tooling that's already been approved by her organization because they have support and things built in, and she needs uptime. if things are constantly changing under the hood with no records of what's going on, then that's not going to work. Now, I am here to propose that we can bring them together, and we're going to do it through MLOps. Now, before I begin, I want to talk about what the EDE machine learning lifecycle looks like. Now, you saw a bunch of boxes connected together with arrows there, but the main things that I think we need to identify and solve for in an EDE lifecycle is what you see here. First, you do have the development and deployment of the model. Then you're going to have to package it in a way that can be used and migrated to in production. You want to validate that model behavior before you roll it out. Then you want to deploy the model, and then you want to monitor it. And in monitoring it, it is not just about having it out there and making sure it's up, but it's in fact taking all that data and feeding it back into the original so that you can now train it again and be smarter about it. So you may say you might have heard this before, and the reality is you have. You heard this several years ago when things started getting kicked off around GitOps. And that was the idea that you could start with Git and record everything that you were doing relative to your overall pipeline, iterate very quickly on that pipeline, and then once that pipeline had passed all its tests and humans had looked at it and said, yes, this is ready to go, you trigger a second cycle. And that second cycle is rolling it out to production. But again, it's all driven off of Git. You don't have someone in the middle there introducing any new changes because those wouldn't have been tested and relied, or tested and observed and made sure that they pass all your bars. And what that really gets to you is those lines at the bottom. You get velocity plus security. So what we need is MLOps, right? And MLOps is going to look like this. Right? You start with the data scientist. The data scientist is able to iterate exactly as quickly as she could, and potentially even faster, because you're giving her the best of breed tools, and you're giving it to her in a system where she doesn't have to think about, well, this Python dependency didn't work with that other package that I had over there. You give her a path to install and manage these things in a very regular way, and then from that, you start the second half, right? You have her finish, you have her check in, and move forward through dev, that's integrating it into the application itself, and then integrate again when it comes to rolling out to production. And when you do that, you get these benefits, right? You get great observability. That means you know exactly what's being rolled out, so you're able to observe it using standard toolings and reproducibility. You get validation. Again, because the stuff is checked in Git, you can do static validation, you can do runtime validation by rolling it out to canaries in a very regimented way. And then, of course, you get reproducibility and auditability. You know that whatever that query was, that prediction that happened at the end of that very long cycle, you're able to trace back exactly what code rolled it out at every step of the way. And in this way, you get velocity plus security for ML. So some of the specific components here, and I'll just walk through this really quickly. Like I said, you have that data scientist. She checks into Git. At that point, you do code set versioning, or you do code, data set, and environment versioning. You snapshot all of those things. From there, it automatically builds both the app and trains the model. And in that, you're able to do hyperparameter sweeps and all those kind of things in an automated way. You validate the model at that testing point using things like model validation and certification and things like that. You release the app, and then finally you roll it out. And so that's what we're going to try and get to here today, and we're going to do it right here on stage for you. Well, technically. So the question is, this sounds pretty good. I'd like to take it on. What should I do in order to achieve that? Well, I have a suggestion for you. You can go join one of these big companies, because they already have it. And they have it. It's, at Google, it's TFX. At Facebook, it's FB Learner Flow. At Uber, it's Michelangelo. Microsoft has our own, which is called Ether. And what this is it's a very standard data science platform, where a data scientist will come in and be able to interact at a very high level, see other people's experiments, see her own experiments, iterate and version on her own experiments, and then basically download and begin to use those experiments. Rather than having to start from scratch every time, she can start there and move forward, rather than resetting everything. So you have rejected my suggestions. That's very harsh of you. I don't want to work at a company. So I'm going to help you by building your own MLOps platform using, first, we'll do it with CI/CD. Second, we'll add in Git. And third, we'll add, start with Kubeflow, go with Git in the middle, or GitLab or Bitbucket or whatever it might be. And then finally, we'll do it with a CI/CD platform. By the way, I hope I did my best. I'm trying to be very neutral here. All logos are the same size. And by the way, if you are thinking of inventing a new CI/CD platform, there are so many. There are so many CI/CD platforms. It's enough. Just help another one. Help one that already exists. I promise you. Okay. So, joking aside, let's go. MLOps in the real world. I'm going to take on a challenge that many people, I don't know if Corey is here. Corey, are you here? I know that you are attending KubeCon, but I'm not sure you're here. Corey doesn't believe that multi-cloud exists. I'm going to say that it does. And I'm going to say it does in the following way. Multi-cloud really does exist in the real world. And I'm going to lay out a very standard scenario and then solve it for you on stage. So, when I say multi-cloud, this is what it looks like. You have, at the top, you have cloud, whatever cloud it might be. And at the bottom, you have on-prem. And again, that's a special case of a second cloud. It could be a second cloud, could be on-prem, could be your local laptop, doesn't matter. And in the middle, you have Git. The reason you've chosen that top cloud is because it's distributed. It's something that your data center can't offer you today. Maybe it's uptime, maybe it's locality because of regulatory reasons. Maybe it's just closer to your IoT deployments, right? You don't want to have that far, big latencies and so on. But the reason you still have stuff on-prem is because you actually have a lot of data that you've been collecting for many years, and it's just a big pain in the butt to move it to the cloud. We see this scenario all the time, and it's whether or not, maybe that's a poor latency connection, or maybe you just don't want to spend, many, many millions of dollars on petabytes of data being held in the cloud because you already have a bunch of disk and it's doing its job. You don't want to do that. So, and then we have our two cast of characters. We have our data scientist. She wants to iterate very quickly on the model and make sure that it works, and she's going to want to train next to the model. But then the SREs and the ML engineers are going to want to host in the cloud. So let's do this. So what she does is first, she's going to check in her code into Git. Git will be watched by the CI/CD pipeline for a new check-in, and that will automatically trigger a Kubeflow pipeline. The Kubeflow pipeline will process the data first in whatever way it needs processing, or if it's already been processed and checkpointed, then it can skip to the next step, and Kubeflow is smart enough to do that. It then will run a training run automatically on that processed data, again, using whatever parameters you've passed in via Git, right? Again, this isn't something where the data scientist is picking it on the fly. You want to be extremely prescriptive about this. Once that's done, it's going to register the model at a central point, which can be picked up, and then rolled out to the cloud. And in this case, you would roll it out to something like a canary endpoint or a staging endpoint to make sure that it runs. A human being often will, after the tests have passed, come by, make sure everything is operating properly. That the human being will then say, okay, it's time for me to trigger the next step. And at that point, it gets rolled out to a public service endpoint and used for the model for production. Okay? So that's the high level. Let's see what this actually looks like when it's running. And can you see this? Yes, you can. Okay. Well, this is going to be very hard because I have to look over my shoulder the whole time. All right, so this is, the one downside of moving into ML is you have to record all your videos because everything takes forever. So I promise you, you can look at the date. I don't know where the date is on. Anyone see a date on there? This is literally run last night, so I promise you, you can go to this repo, which is public, and download all the code and have a good time. Okay, where are you? Okay, so first, is this running? It is. Okay, so first what you see here, this is a very standard repo out there, and it's got all the code in it. And let me show you actually exactly what this code looks like here. You see this? You cannot. Uh-oh. Okay. There we are. Okay. So they always say never show code when you're doing a demo because everyone's eyes glaze over. But this is a very smart room, so I'm going to trust you. Your eyes are not going to glaze over. So what you have here is, this is a very, very standard CI/CD pipeline. This is using Azure DevOps, which is something that we use for hosted DevOps CI/CD on Azure. But the YAML is going to look super familiar because it follows very standard CI/CD practices, looks just like Jenkins. And what you see here is at the top, you see a trigger. That means it's triggering off the master once you check in. And here you have individual steps. This, in fact, does a build of a container. And we do 3 builds here because that's what Kubeflow requires. Kubeflow needs every one of your steps to be built into a container. And then you roll that forward and into your Kubeflow pipeline. And what you're rolling in, what the pipeline looks like, is this. Actually, why don't I get to this in just a second? So we'll go back to our video here. And like I said, what you see is a standard repo. Where's my thing here? And that was just the code that you saw me pointing at earlier with standard pipelines. And this is a very important one. It does burritos versus tacos. You upload, and it'll tell you whether or not something's a burrito versus taco, which is a harder problem than you would think. You know, is it a half-open burrito? What if it's, you get the idea. All right, so we're moving on here, and you can see what it's doing is this code that's in the repo right now is doing transfer learning using a very standard transfer learning tool called MobileNet, and so we layer on top of that. So, like I said, this is just incredibly standard pipeline code, and these are the pipeline steps that you'll see here, and I'll dive into those in just a second. But the idea is that we want to show how when you check in, it's going to kick all these things off. So we come back here, and we're going to hit merge on our pull request, and it's going to kick off. There we go. So we're hitting merge, and off we go, and there you go. So this is the UI for Azure DevOps. Again, all we did was hit merge, and all this kicked off. So at this point, we're going to go forward. You can see there, right there, build number 9 has just kicked off, and that is, May 21st. So I'm being honest here, and you can see how the things are transpiring here. So in this case, it's going to go through those 3 build steps, where it builds each one of the containers using standard Azure build tools. And again, this can be Docker, this could be Builder, this could be anything that makes sense for you. And you've all seen Docker build many, many times, so I'm going to fast forward through those. Okay, and then this last step is where you take all those containers, and now you've uploaded them to, in this case, ACR, but it could be any Docker registry. Okay, so now that is done. And now we have the interesting bit, because that is the build pipeline. Our steps here are first we kick off a build pipeline where it takes those containers and builds them, and then we do what's called a release pipeline. And you want those to be separate, right? You want to make sure the build is complete, that all the artifacts pass and are ready to go. And now we're going to do this release pipeline, and the release pipeline is where it reaches out to Kubeflow and executes. And you can see this here. It's reaching out using a Swagger client that we wrote to connect directly to the Kubeflow API. You can see there it's forwarding the connection. And here, you can see the run. These are the runs we had previously. We're up to run 84. We had a lot of debugging. Not Kubeflow's fault, our fault. And presto, we're at run 85, right? So again, I want to call back because this is a small but special thing. All I did was hit git. All I did was check in and merge my final PR, and it kicked off all of this goodness. So now we're sending through here, and you can see, are we running? No, okay. So this is a standard Kubeflow pipeline. I already described it. It does pre-processing. Here it's mounting in Azure Blob, and you can see it watching the logs right there. And you can see the artifacts. Once that's done, it automatically moves forward. The container's being created. And here it's actually doing a training run right now. It's using the latest TensorFlow 2.0, you can see. And not just TensorFlow 2.0, but let me just highlight that right there. It's using GPUs natively on Kubernetes directly through this check-in. Okay? And it's going to operate and run quite fast, much faster than it ran when it was running on my local machine. And we go forward there, and now it's doing registration. And this is where you start to mix and match between things running in Kubeflow and things that you may want to run in the cloud. So in this case, it's going to do this last register step. In Azure, we have a service called the Model Management Service. This is basically a sophisticated storage location which understands machine learning concepts in a first-class way. And by that, what I mean is you're able to understand whether or not something needs versioning, how to compare versions within each other, what the performance of something is, and you're able to visualize it in a first-class way. And so what it's going to do here at this last step, here are 3 versions that we ran already. And once it's done, you can see here, this is the model registry service. It's going to kick it off any minute. Moving forward. Yeah, okay. So you can see here, it's using, in this case, the Azure SDK natively inside of Kubeflow. It's able to reach out. And you can see they're using our service principals, service passwords, the subscription information. It's able to take that HD5 file and simply push it up to the model registry service, which then will kick off the second half of the solution. And you can see it there. So that's roughly what it is, rolling things out. Here's where you can see some of the richness that we're able to upload and the metadata that we have relative to these things. And no, I don't need you. There we are. So that's what MLOps looks like in reality, right? And from that point forward, I just rolled out a service endpoint. Everyone's seen that, right? Nothing special there. But that's what we're talking about. This is something where you had a Kubeflow cluster that was in no way connected to any of the more sophisticated Azure or other components. It was just running standard Kubernetes and standard Kubeflow. And the reality is that gives you the opportunity to do the training in a way that makes sense for your organization. You don't have to take your data. You don't have to change the way your processes work. You don't have to adopt some crazy new standard just because that looks slightly faster. This is an open platform where you can pick and choose and plug in the components that make sense to you. And that's the power that things like open source and things like Kubeflow provide. Now, I know what you're saying. It sounds like a lot of work. I would like to recall this statement here. You know what's a lot of work? 11 months sitting around without your model shipping out to production. That's a lot of work. This, okay, you have to spend a few minutes making sure that service principals are able to cross clouds, but other than that, you'll be fine. And you're not just fine, right? You're actually moving faster. And that's what we're really trying to provide here. Data scientists understand their problem areas, but too often they have thrown things over the wall and asked production to ultimately, deal with a lot of the hardness. What we're saying is we want to bring, through things like MLOps, we want to bring the same advances that GitOps brought to app developers. We want to help data scientists be part of how to bring things to production and get end-to-end ownership. And even better than that, help them learn real software engineering best practices. Like for too long, we've said, hey, data scientists, don't worry about, SWE best practices, come back when you're older. No, that is not okay. These are software engineers. They want to help get things into production. They want their models to be used just as much as you do. We need to help them bridge the gap, but not by forcing them to, figure out how to do Git branch strategies. On top of that, it enables continuous delivery. The automated pipeline that you saw earlier can be automated every night. And that is something that we learned, for years. All of those big production clients you saw there that were able to continuously iterate using these MLOps platforms, they're all moving or have already moved to continuously training these models. And the reason is because unlike a lot of software, models go out of and go stale very, very quickly. You need to continuously train them. You need to continuously watch your data and make sure things haven't drifted one way or another. People change, code changes, situation changes. Continuous training is the only way that you're going to be able to deliver value at scale over time. And then finally, it's impossible to overstate how much value you get by instituting these things around lineage and auditability. Unless your code is checked in and everything is moved forward from that point, you will not be able to defend in a court of law or to your execs or to the software engineer sitting right next to you exactly what's going on in production. And again, because we haven't spent the time yet to make MLOps easy, we're putting that that onus on the work of the software engineers and the data scientists to build their own solutions, and oftentimes they're going to miss something. So it's up to us to give them a great platform to do that. I always like to end this slide with, or I always like to end my talks with a slide like this, because it's so important. The reality is that the people in this room and the people watching on the video, you're already there. You already know a lot of this stuff and you're working towards this. Data science will affect every industry in the world. ML and AI will affect every industry in the world. It's up to us to figure out how to bring our data science to these people and help them, the people who have domain knowledge, be smarter about what they're doing. Kubeflow is open. We would love for you to come and contribute to all of the work we're doing around Kubeflow with MLOps. You can see a bunch of the things here. Everything that I demoed on screen is open source and ready for you. Obviously it is built on Azure pipelines, but like I said, that's very portable to other pipelines, and we would love to help you do that. We actually have an entire repo dedicated to MLOps, and we're hoping to move that from, right now it's hosted under the Microsoft one. We would love to host it in a more general place where people can share. And then, of course, in Kubeflow, we're talking about MLOps constantly. The work that we're doing around pipelines is specifically designed to help solve this very critical problem. Let me give a quick shout out to other talks here at the conference around Kubeflow. Please go, and other than that, thank you very much for the time. Okay, with that, we have a few minutes for questions. What can I answer for you?
If anyone has a question, make yourself visible and I will bring the microphone.
Nope.
Yes, one.
Everyone's running in production? I don't believe any of you.
Do you have any examples of hyperparameter tuning using KTib?
Sample runs using KTib. There are examples right now in the Kubeflow repo for how to run it, but we haven't built a specific MLOps pipeline for that yet. I think that's a wonderful thing, and I'd love, if you're interested, I'd love to collaborate with you, but that's a great thing that we can work on soon. What else? Yeah.
Hi. What's your recommended approach to versioning large data sets? I mean, when there are huge amounts of images or videos?
So we do get that question all the time. Most data providers today will have a way to do snapshotting or versioning. A lot of it comes down to what the underlying data set. Oh, sorry, the question was, what's your best practice for versioning data sets, checkpointing, and things like that? So a lot of large data providers, Spark, Hadoop, SQL Server, MySQL, so on and so forth, they'll have ways to accomplish this in their own systems. But a lot of it comes down to what does the immutability of your data look like? If you have a practice, a best practice around, for example, audit trails for your database, then that might be enough, right? You could simply say, okay, I'm going to do select star from table that I like between January 1st, 1970 and January 1st, 1980, right? That could be enough. You could simply say, okay, I'm done, and as long as that data set hasn't changed, then that's enough, because I know I can always go back and recreate that. If you need things like deltas and more complicated structures like that, our recommendation is to work with whatever data provider you have, because most of them have it. There are also a number of open source tools that are doing some very interesting things around this. Pachyderm has some stuff. DVC has some stuff. There's a bunch of really interesting stuff around this right now. But the net is I would start with wherever you're storing your data today and then go forward from there. We do get that question a lot, though, so if you have thoughts around that, I'd love to pull it into Kubeflow and some of these other work.
So, if I understand correctly, there are two main pipelines, one for training and one for the serving. And do you versioning the model created by the training pipeline?
How do I version? So the question was, there are two main pipelines that I demoed on stage. How do I version the model? Is that what you said? Yeah. Okay, so as you saw there, in fact, what I use is a service from Azure called Model Management Service. There are many services out there. ModelDB is one, and that's already integrated with Kubeflow and so on. More often than not, what you'll want to do is you'll want to have your model registry service, whatever it might be separate from your Kubeflow deployment, because oftentimes those exist in different planes, and one has a much longer persistence than the other. Kubeflow is oftentimes brought up and torn down quite regularly, whereas your model registry, you'd want that going on forever. To be clear, though I demoed 2 pipelines on stage, that could have been 1 pipeline, that could have been 6 pipelines. It's whatever makes sense to you. Generally speaking, your best practice is to have 1 pipeline per environment, if you will. Because that, or per particular function. So what you didn't see here is, for example, oftentimes you'll have a data pipeline for doing your overall sharding and processing of your data, moving it to its final location. I did pre-processing as part of the pipeline that you saw on stage. But like I said, you could use the Azure Model Management Service. That is, nothing about Kubeflow is required there. It's just an open endpoint, and you could use something like that, or you could use anything that you would want to host yourself.
But in the end, it's a binary file.
Sorry?
It's a binary. We're speaking about a binary file, not another container.
The model is just a file? Yeah, so yes and no. The model is just a file. That is absolutely correct. But as you saw there on stage, what you'll frequently want is more information about the model or more sophistication about how to store that model. So as you saw there, I recorded that even though there were in fact 4 different models there, they were all part of a single model training job, if you will. And they had different versions. And the reason you want to do that is because that will give you the opportunity to do inter-model comparison over ongoing training runs and so on. Again, that is absolutely something you can achieve yourself. Though I talked about Azure, this is something you can definitely do. It's just a matter of if you want to host it yourself or have someone else host it.
Thanks.
No, you're just stretching. Okay.
Other questions?
One here.
I noticed at the beginning of the Azure pipeline, there was a kind of preliminary step to build some containers. I guess those containers or the images are used in the Kubeflow pipelines. What do you think about the idea of bringing the image building step within the Kubeflow pipeline itself, so that the pipeline could become entirely portable?
Yeah, the important thing to take away here are the steps and the pipeline. The not important thing to take away is the exact things that we chose. So for example, there is already a container builder inside of Kubeflow. That could be perfectly great for you. We just happened to choose this one because the software engineer and I who were working on it knew how to do that very quickly. And so that's basically it. Again, you do want to, the more important bit is you want to store those artifacts or both the commands you use to execute it and the artifacts you want to store separately so that they persist beyond a single run. That answer your question?
Yeah.
Okay.
Great. I think we're pretty much at time.
We are at time, but anyone, and I'll be up here and I'll be around, whatever you like.
Thank you very much.